We exchange stocks, money for goods, love with our family. But what about the most important exchange of life? The gas exchange. It all starts with nerve signals ordering muscles to contract in order to expand the lungs. This slightly decreases the pressure in the lungs. Gases tend to go from high pressure to low pressure. Thus, air rushes into the lungs and you inspire. Let's zoom into an alveolus, the fundamental unit of the lungs where all the magic happens. Oxygen that comes to the alveolus has a partial pressure, the amount of pressure the gas contributes, of about 104 millimeters of mercury. The surrounding capillaries carry blood depleted in oxygen and thus have a lower partial pressure. The capillaries are fused to the alveolus, allowing for easy diffusion of oxygen into the capillaries. Inflammation of this fused membrane and fluid in the alveoli, as is the case in respiratory diseases like pneumonia, as seen in COVID-19, hinders this diffusion and often leads to shortness of breath and hypoxia. As oxygen diffuses to the lower partial pressure, most of it binds with a molecule called hemoglobin. Hemoglobin consists of 4 heme groups, each with an iron atom to which oxygen binds. Although it is harder for the first oxygen to bind, it's much easier for the following molecules. Kind of like how it is hard for a trend to get started, but once it is, more and more people join it. This phenomena is called cooperativity. However, this trend doesn't last forever. The remaining oxygen is dissolved into the watery plasma of the blood, similar to how carbon dioxide is dissolved into soda. Loaded up with oxygen, the blood is pumped via the heart to the tissues of your body. The tissues, burning through oxygen as they undergo aerobic respiration, have a lower partial pressure of oxygen. Additionally, their metabolic activity releases heat and carbon dioxide as a waste product. The lower partial pressure and heat already attract oxygen to the tissues, but the tissues still have more tricks. CO2 follows the partial pressure gradient and rushes into the blood. Some of it gets dissolved into plasma. A lot of the CO2 reacts with water to create carbonic acid, which breaks down into bicarbonate and hydrogen ions. The hydrogen ions and the remaining carbon dioxide further drive out oxygen. Like a paper fortune teller, hemoglobin has multiple binding sites and can bind oxygen, carbon dioxide, or hydrogen, but not all at the same time. So, carbon dioxide and hydrogen compete with oxygen for a spot and eventually kick out oxygen, leaving it for the tissues. This effect is called the Bohr effect. The competition between the molecules lowers hemoglobin's affinity for oxygen. This allows for greater oxygen delivery to the tissues. The blood, with CO2 stored as bicarbonate bound to hemoglobin or dissolved into plasma, arrives back at the lungs. The Haldane effect, the opposite of the Bohr effect, sees oxygen compete and kick out CO2 and hydrogen ions from hemoglobin. The CO2 diffuses into the lower partial pressure of the lungs. You exhale and the cycle restarts. So, at every breath and every exchange, remember the essential exchange of life.